So today we're looking at chapter 10, right? So we're moving past linear system of equations and we're going into order of real numbers and inequalities in one variable. So to start off, let's remind ourselves, how the order of real numbers works. We always start, usually our center is 0, right? And then if we want to go less than 0, we go into the negative numbers. If we want to go greater than 0, we go into the positive numbers. And a negative number is smaller than a positive number. And the three signs we're going to be looking at are inequality signs. We've got less than, greater than, equal to, as well as less than or equal to and greater than or equal to for conditions, right? So to begin, we're on page 460, okay, and we're looking at true and false statements of inequalities. We need to show if this statement given is true or false. So in 16, we're given 0 is less than or equal to the absolute value of 16. Now, less than or equal to means that it's either less than or equal to. It doesn't necessarily have to be both. So we know that 0 less than or equal to absolute value negative 2 is the same thing as 0 less than or equal to 2, right? Because absolute value of negative 2 is positive 2. Now, 0 is less than 2, but it's not equal to 2. And that's okay because it can be either less than or equal to. It doesn't have to be both. So this statement is true. For 18, we're given the absolute value of negative 0.5 less than or equal to negative 0.5. So we're going to evaluate that absolute value to a positive 0.5. And we see that we've got a negative value has to be greater than a positive, which we know can't be possible. So this is false. For 20, we've got negative 6 less than 1 less than 7. So it's saying that negative 6 is smaller than 1, which is true. And then 1 is smaller than 7, which is also true. And that negative 6 has to be less than 7, which is also true. So the entire statement is true. Let's do another one like that. In 22, we're given negative 5 less than negative 4, which is less than 4. So negative 5 has to be less than negative 4. That's true. Negative 4 is less than 4. That's true. And negative 5 is less than 4. That is also true. So the entire statement is true. Now let's look at 26 and 30. In 26 and 30, they're going to give us an inequality statement with a variable, and they want us to solve for certain values of x. So if you look closely at 26, the values we need to solve for are negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, and 4. So what we're going to do is we're going to plug in every single one of these values to see if they satisfy the inequality. So we'll start with negative 4. Negative 4 plus 2 is less than 3. Negative 2 is less than 3. That is true. So negative 4 is in there. Negative 3 plus 2 is less than 3. Negative 1 is less than 3. That's also true. Negative 2 plus 2 is less than 3. 0 is less than 3. That's good. Negative 1 plus 2 is less than 3. 1 is less than 3. Yep. 0 plus 2 is less than 3. 2 is less than 3, yes. And 1 plus 2 is less than 3. 3 is not less than 3. It's equal to 3, so no. And it stands to reason that 2, 3, and 4 would also produce that. So let's just double check. 2 plus 2 is less than 3. 4 is less than 3. Not true. 3 plus 2 is less than 3. 5 is less than 3. Not true. And 4 plus 2 is less than 3. 6 is less than 3. Not true. So our answers are from negative 4 to 1, so we're going to write that in set notation. So our answers are negative 4, negative 3, negative 2, negative 1, 0, and 1. Now let's look at 30. In 30, we're given x squared is greater than or equal to 4, and we're using the exact same numbers for x as we did in the last one. So we're just going to plug in values for x. So we start with negative 4. That's going to be negative 4 quantity squared less than or equal to 4. That's 16 less than or equal to 4. Not true. Negative 3 is quantity squared less than or equal to 4. That's 9 less than or equal to 4. Not true. Negative 2 squared less than or equal to 4 is 4 less than or equal to 4, which is true because 4 is equal to 4. Negative 1 quantity squared is less than or equal to 4. 1 less than or equal to 4. That's true. 0 squared less than or equal to 4. 0 is less than or equal to 4. That is true. 1 squared less than or equal to 4. 1 less than or equal to 4. True. 2 squared less than or equal to 4. 4 is equal to 4. That's true. 3 squared less than or equal to 4 is 9 less than or equal to 4. That's not true. And 4 squared less than or equal to 4, 16 less than or equal to 4. Not true. So our answer is from negative 2 to 2. So we get negative 2, 0, 1, negative 1, and 2. I'm going to put that back in order. So that's going to be negative 2, negative 1, 0, 1, and 2. Okay, so let's move on to some graphing. So for 32, we're given the statement that h has to be between 2 and 8. And then they give us a domain, so that's a limitation on our h's, in that we're only looking at positive integers. Remember, integers are whole numbers, right? So we can't include stuff like 1 1/2, 3/4, 1/8, that kind of stuff. So we're going to draw our graphs. We have 0, 1, 2, 3, 4, 5, 6, 7, and 8. And then we know that since it's between 2 and 8, right, we know that 3 is an answer, 4 is an answer, 5, 6, and 7. And you're probably wondering, well, why don't we mark 2 and 8? And that's because, if you remember, the less than signs with no equal, as well as the greater than signs, are non-inclusive. That means the endpoints, 2 and 8 in this case, aren't included, whereas less than or equal to or greater than or equal to are inclusive, so their endpoints are included. In 38, we're given the interval 4 to negative 5, where 4 is greater than or equal to n and n is greater than 5. Negative 5, and then we're on the negative integers this time. So I'm going to graph starting with 0. Okay, and then because we are greater than 5, non-inclusive, our answers for negative integers are going to be negative 4, negative 3, negative 2, negative 1, and then we're going to stop there. Even though n can go up to positive 4, we only want negative integers, and those would be negative 4, negative 3, negative 2, negative 1. And again, we don't include negative 5 because it's not inclusive there. So let's then move on to 10.2. In 10.2, we're solving inequalities. So I've written out the steps for solving inequalities. Step 1, simplify each side of the inequality as needed. Okay. Step 2, use the inverse operations to undo additions or subtractions. Step 3, use the inverse operations to do any multiplications or divisions. Okay, so all we're really doing here is just solving for a or x or whatever variable we have, but instead of having an equal sign, we're going to have an inequality sign. And then we're just going to graph our solution set. So in 12, we've got a plus 3 is greater than 11. So you want to simplify each side of the inequality as needed. It's already simplified. Step 2 is use inverse operations to undo additions or subtractions. So inverse of addition is subtraction. So we're going to subtract 3 from both sides. We get that a is less than 8. Okay, so then when we go to graph this, we draw 8 in the middle, 7, 6, 5, 4, 9, 10, 11, 12. And then it's less than 0 with no equal sign down here. So that's an open circle on 8, right? Because less than or greater than is an open circle. Less than or equal to, greater than or equal to is a closed circle. So less than 8. So it's going to be everything to the left of 8, like so. And there's our graph. Now let's try 14. 14 says 4q is less than 12. So we have to simplify each side of the equation. Already done. There are no additions or subtractions to use inverse operations on. And so then we go to the third step, which is multiplication or division. And so multiplication or division, we're going to divide both sides by 4. Q is less than 3. So we're going to draw our numbers. 3, 2, 1, 0, -1, 4, 5, 6, 7. And this one again says that Q is less than 3. Okay, so we have an open circle on 3 and then an arrow going to the left. There's your graph. For 16, we're given -6 is greater than s over 3. So again, we have to simplify each side of the equation. Already done. No addition or subtractions, but there is a division, so we're going to multiply both sides by 3. So we get -18 is greater than s. Okay, so I'm going to draw. I've got -18, -17, -16, -15, -14, -19, -20, -21. And then we're going to start at -18 with an open circle and then go towards, go away from the positive side because -18 is larger than our s values. So we're going to go to -19, -20, -21, and so on. Best way, if this confuses you, is to just test. So say we picked -21. Is -21 less than -18? It is, so that's in our solution set. Okay, let's check out some other ones. So let's first look at 18. It says that -5w is equal to 15, is less than or equal to 15. So first thing we're going to do is divide by 5, well, -5, right? Now here's the tricky part. When we divide by a negative, we flip the sign. So instead of being w less than or equal to -3, it's going to be w greater than or equal to -3. And remember, multiply or divide by a negative, flip inequality sign. Okay, and that's only when you multiply or divide. If you subtract or add, it's not going to change your sign. Okay, so then let's graph. So we're going to plot -3, -2, -1, 0, 1, -4, -5, -6. W is greater than or equal to -3, so we're going to have a closed circle for once. And since w is greater than -3, we're going to go towards those positive values and 0. For 24, we've got -4 greater than or equal to 4 minus u over 2. So first thing we can do is subtract 4 from each side. We get -8 is greater than or equal to -u over 2. We're going to multiply both sides by 2. So we get -16 is greater than or equal to -u. We're going to multiply everything by a -1 now. So we get that u is greater than or equal to 16, because again we multiply by a negative, so it flips. And then we graph. So we've got 16, 17, 18, 19, 20, 15, 14, 13. So 16 is less than or equal to u, so u has to be greater than this. We're going to put a closed circle on 16 and then go towards higher positive values because u is greater than the value we have been given. For 32, we've got 8 minus 2b is greater than 4 minus b. So again, first thing we're going to do is we're going to get all the b's on one side and everything else on the other. So I'm going to add b to both sides and subtract 8 from each. So we get negative b is greater than negative 4. We're going to multiply everything by a negative 1. So b is less than 4. So we've got 4, 3, 2, 1, 0, 5, 6, 7. We've got a less than, not a less than or equal to, so an open circle on 4, and then goes towards those negative values because b is less than 4. 3 more problems. 34. 8 is less than 2 times 4 minus m. So first thing we got to do is simplify both sides of the inequality. 2 ways of doing this. We can either distribute or we can divide by 2. I'm going to go ahead and divide by 2. So I get 4 is less than 4 minus m. Now I'm going to subtract 4 from each side. So I get negative m is greater than 0. Multiply everything by a negative 1. So m is less than 0. Okay, so I'm going to go ahead and put an open circle there, and since m is less than 0, I'm going to go towards that left side. 36. 7a is less than 3 plus 7a minus 1. So unlike 34, I cannot just divide by what I'm multiplying by on that right side to the parentheses. So instead I've got to distribute. So I get 7a is less than 3 plus 7a minus 7. Now I'm going to get everything with an a on one side and everything without an a on the other. So I'm going to subtract 7a from each side, and I get 0 is less than negative 4. This is not possible, so there is no solution, right? Because 0 cannot be less than negative 4. If we had gotten negative 4 less than 0, then this would be all real numbers, right? Because no matter what number I plug in, I'm still going to get out that 0 is less than negative 4. Negative 4 is less than 0. It just happens that this one is the opposite. So there is no solution here, and there is therefore no graph. 38. 4 times 2 minus v is greater than or equal to negative times v minus 5. So I'm going to first distribute everything through on both sides. So I get 8 minus 4v is greater than or equal to negative v plus 5. I'm going to add v to both sides and subtract 8 from each side. So I get negative 3v greater than or equal to negative 3. Then I'm divide both sides by negative 3. So v is less than or equal to 1. So I'm going to start off by drawing a closed circle on 1 and then continuing an arrow towards negative 2 there. And that's my answer. All right, and those are the lessons. The homework is page 460, 15 through 37 odd, and page 466, 11 through 39 odd. This will be due Wednesday, the 8th of March. I really do appreciate you guys sticking with me on this and really trying to finish this before the quarter ends. So in light of that, remember your test is going to be this upcoming Thursday on just these 2 sections. Okay, we will have time on Wednesday to study that. And I'm looking forward to this week.